electronics. Today's class we are going to see some previous year questions from the AFCAT examination, that is for the Air Force. The examination is going to happen, and there is two parts for the examination. One is the common examination where you are being tested for a general aptitude, reasoning and everything. Then there is an engineering knowledge test for the technical branch. It is conducted for 150 marks. There is 50 questions, 3 marks for each question and 1 mark negative marking. So that is a part 2 of the selection process. Okay, so the AFCAT examination is for Air Force. There are 66 vacancies for the post of technical for electronics specifically. So if you belong to electronics and communication or electrical and electronics or any branch of electronics, you can apply for this post. Okay, so let us see some of the previous year questions from this examination which happened in the previous years. We are going to see. Okay, though if you are preparing for any of the common examinations or any of the competitive examination of electronics, you can see this video because I have tried to include new concepts along with each answers. This is the first question. Crossover distortion does not occur in dash. Option A, push-pull. Option B, class A. Option C, class AB. Option D, class B. Okay, so if you see the examination, engineering knowledge test examination of AFCAT, you can see that mostly the questions are simple and covering the basic concepts, the core concepts of electronics from your core subjects they will be asking. There won't be much tough questions or numerical type questions. I have not seen over the question papers of previous year questions. Basically, they will be testing your knowledge, mostly theory knowledge. Okay. But there will be some questions from the digital electronics like logic gates or number systems. I have seen questions, but not very complex from the, for example, from the network for solving. Not so much of difficulty is not there in the examination. Okay. Anyway, you should be thorough with the concepts. Okay, so for this question, crossover distortion. What is crossover distortion? It is a type of distortion happening in complementary amplifiers. For example, if you're having one NPN transistor and a PNP transistor like this. So this is a NPN, sorry, this is a PNP transistor. This is a NPN transistor. So this is a class B amplifier. Here you are going to give your input. Here you will be taking your output. Okay. So why we are using amplifiers actually? In order to amplify the signal. So if you are giving such a signal, you should get an amplified version, right? So this is your ideal or your expected output. But what happens in these type of complementary amplifiers is that the output will not be exactly this what we expect. Now, what is actually a complementary transistor? Complementary amplifier means it is using two complementary transistors. For example, NPN and PNP are complementary. Okay, or NMOS and PMOS, they are complementary. So, likewise, if you are using these complementary type of transistors, we say that as complementary amplifiers. Okay, now, what happens is that when the signal is crossing the zero or when the signal at the output, I'm talking, when the signal is crossing the zero, the wave will be little distorted. I'll tell you. See, it won't be like exactly like this. There will be some distortion. Here also, for all the zero crossings, there will be some distortions, right? And this distortion here is called crossover distortion. That is crossovering of zero. Now, why this crossover distortion is happening, I'll tell you. Ideally, what we expect, we are giving some input to this transistor. We should have an exact amplified version of that signal, right? But if you see this signal is passing through 0, then slowly rising from 0, 0.1, 0.2, likewise. And also, there is some condition that in order to turn on the transistors or the junction, we know that transistors are basically PN junctions, right? Two PN junctions form one transistor. So, ideally to turn on the PN junction or the transistor, say, or the base emitter region of the transistor, we need a cutoff voltage, right? So for a silicon transistor, there will be 0.7 volt as a cutoff voltage required to turn on. Only then the transistor will start conducting. Only when the transistor is starting conducting, the signal is amplified. Otherwise, it is not. So, from 0 to this 0.65 or 0.7 ideally, there won't be any output. Okay, so there will be some distortion because only when the transistor is conducting, the signal is amplified or the output is generated, right? So from the 0 to 0.7, the signal is not actually at the output side or the transistor won't be conducting. Now we know that for the positive half cycle, one transistor is conducting. For the negative half cycle, next transistor is conducting, right? So likewise, each transistor will take this crossover time period or crossover voltage to turn itself on. So when the signal is passing through this 0, the one transistor is getting turned on, but it is taking a little time to turn on. And this distortion at the 0 crossing is called as crossover distortion. And this crossover distortion are being seen in complementary circuits like this. For example, push-pull circuits or class B and class AB type of transistors are using this complementary configuration. But in the class A, there is no such configuration and hence class A doesn't have crossover distortion. Okay, so the answer for this question is option B, which is class A amplifier. I hope the concept of crossover distortion is clear to you now. Next question is subtracting of 0101 from 1110 in binary will get dash. Now we know in binary, in order to subtract a number from another number, we take the number to be subtracted, take its 2 complement and add with the other number. That is a procedure. So I am going to do it. So we need to subtract this number, that is 0101 from 1110. So first I will write this number 1110 and then this number is to be subtracted. So take its 2's complement, that is 1's complement plus 1. 1's complement means taking the complement of all the bits. That is 0101, 1's complement is 1010. Sorry, it is 1010. Then plus 1 to make it 2's complement 4. So 1101. 1101 is the 2's complement of this number. Now add this 2's complement, that is 1011 with the next number. This is the procedure of subtraction. So 1, 1, 1 said 0, 1, 0, 1. So 1 and carry 1. So the output is 1, 0, 0, 1 with the carry 1. So we can neglect the carry as of now. We have not given that. So 1, 0, 0, 1. The answer is option C, which is 1001. So in order to subtract two numbers in binary system, what will we do? We take the 2's complement of the number to be subtracted and add with the other number. Okay, so the correct answer is option C. Question is, in a 2-cavity klystron, the input cavity resonator, also known as dash. Option A, velocity modulator. B, catcher cavity. C, buncher cavity. D, accelerator. So, we'll see the general structure of a 2-cavity klystron. So, there is one, I'm just drawing a rough figure. So, it is a cathode here. There is one cavity here, like this. This is one cavity where we are going to apply our input, that is microwave input. I'm going to apply here. Okay. Then there is next cavity here, and from where I'll be taking my microwave output. So micro output I'm going to take. So here I'm going to apply, I'm going to take. Then there is a collector here. Collector. Okay. Okay. So this is the structure. Here we are going to apply input. Here we are going to apply, take the output. The question is, what is the name for the input cavity? This cavity is called buncher cavity, where we are going to bunch our electrons and we are going to collect these bunched electrons in the second cavity, which is called the catcher cavity. So this is buncher cavity and this is catcher. Okay. So you should be familiar with the simple structure. So I hope this is easy to remember, right? Bunching the electrons here, collecting the electrons here in the catcher after the catcher cavity. So there are two cavities, buncher cavity and captured cavity. Okay, so that is the answer for this question. And the answer is option C, which is buncher cavity is the input cavity resonator's name. Next question. Decimal equivalent of E5 is dash. So this is a hex number, right? So this is a hex number. How to convert a hex number to decimal number? The easiest way, I've explained in one of my earlier videos, that the easiest way is to convert this number in hex to binary, then convert to decimal. Okay, I'll remove this and write it here. So the number is E5, right? So E5, since this is a hex number, that is to the base of 16. How to represent it in binary? We know that hex means we are going to make pairs of 4. So we'll write each of these numbers as pairs of 4 binary numbers. E means 15. So 1, 1, 1. Sorry, E means not 15, it is 14. 0. Then 5 means 0, 1, 0, 1. Okay. So this is the binary representation of E5 as 4 digits. See, 4 digit here, 4 digit here. Okay. Now I'm going to convert this into which format? Decimal format. Decimal means to the base of 2. So 2 raised to 2. I'll write it in below these numbers. Here 2 raised to 0, 2 raised to 1, 2 raised to 2. 2 raised to 3, 2 raised to 4, 2 raised to 5, 2 raised to 6, 2 raised to 7. That is, below each number I have written the weights in binary representation. Now I can cancel off the numbers above which there is a 0. So I'll remove this, I'll remove this, I'll remove this also. Now there is 2 raised to 7, 2 raised to 6, 2 raised to 5, 2 raised to 2 and 2 raised to 0. I've removed all the numbers above which there was 0. Now I'm going to add these numbers. That is 2 raised to 7 into 1 plus 1. No need to multiply with 1, right? Because we know that this same only. So 2 raised to 6 plus 2 raised to 5 plus 2 raised to 2 plus 2 raised to 0. And if you take this, you will get the number as 229 is your answer. So this is how easily you can convert a number from hex to decimal format. So the correct answer is option B, which is 229. Next question is, in 8085 microprocessor, the highest priority interrupt is dash. So if you have done this in your BTech, then you will be familiar with this. Option A, INTR. Option B, RST 5.5. C, RST. D, trap. The correct answer is trap is the highest priority interrupt in a 8085 microprocessor. There are basically 5 interrupts in 8085 and I'll write the interrupts in the priority order. The first one is trap, then RST 7.5, RST 6.5, RST 5.5, then last one is INTR. So this is the priority order. Highest priority is this. So 1, 2, 3, 4, 5. Okay, so the highest priority is trap, which is a non-maskable interrupt. Then these are RST 7.5, 6.5 and 5.5 are maskable interrupts. INTR is a non-vectored interrupt. It is not having a specific vector address. Such type of interrupts are called non-vectored interrupts. Now this trap can also be represented as RST 4.5. It is not a maskable interrupt. So that is having the highest priority and this is the priority order. So if you are preparing, you can note this down. These are the priority orders of the 5 interrupts in 8085. Next question. Schmidt trigger is used as dash. Okay, I'll remove this now. So what I'm trying to do is, while explaining each question, I'm trying to give you some concepts also about the question. Rather than just saying the question and answers, you won't be getting any benefits, right? So while studying each question, you should have, I'm not saying the whole concept, but you should have a small, at least a figure or a small information about each question. So I'm trying to do that in all my videos. I think that is also useful for you. Anyway, next question. Schmidt trigger is used as dash. A, comparator. B, square wave generator. C, flip-flop. And D, all of this. Schmidt trigger or Schmidt trigger is used as all of this. Schmidt trigger is actually an amplifier with a positive feedback. So this is a feedback and it is a positive feedback connected to the amplifier. Okay. So this is the structure of a Schmitt trigger. So this Schmitt trigger is actually a comparator circuit. And we know that mostly if the comparators are used, the output will be square waves, right? So the Schmitt trigger is a comparator and the output will be square wave. So it can be used as a square wave generator. So option A can be used. It is a comparator only with a positive feedback, and it is also a square wave generator. And flip-flop is also correct because Schmitt trigger can also be used as flip-flop, because we know that flip-flops also give zeros or ones according to the input, right? So here also it is giving zeros and ones according to the variation in your input. So Schmitt trigger can also be used as flip-flop. If you see the application of Schmitt trigger, you can see all this: square wave generator, flip-flop, all of this. So the correct answer will be all of this is your answer. Option D is the correct answer for this question. Schmitt trigger is used as comparator, square wave generator and flip-flop. And also there are various other applications. So the correct answer is option D. P-type semiconductor as a material hole is dash. A. Positively charged. B. Negatively charged. C. Electrically neutral. D. Dipole. What will be the answer? We know that P-type semiconductors having more what? Holes. N-type semiconductor have more electrons. But as a crystal, as a whole material, they are electrically neutral. This thing should be always been kept in mind. We know that they are having more holes, and N-type is having more electrons because of the acceptor atoms in P-type. In P-type we use acceptor atoms, right? In N-type we use donors. But as a total material, they are electrically neutral only. Okay. So the correct answer is option C, which is electrically neutral. Next question. Dash is used for keeping oscillator frequency away from drift. Okay. Options are A. PLL, B. VCO, C. Comparator, D. Frequency synthesizer. A. PLL means phase lock loop. B. VCO means voltage control oscillator. C. Comparator. So we already have an oscillator. We don't need a PLL or VCO. They are separate circuits with common phase or common that is control systems there. But in order to keep the frequency of an oscillator away from drift, we only need a comparator. So the answer is option C, which is comparator. Comparator is used in the oscillator, along with the oscillator, to keep away any changes in the frequency or drifts in the frequency. Okay, so the correct answer is option C, which is comparator. So these are the questions which I have included in this video. We'll be seeing in the next part of this video with more questions, and we'll be discussing new concepts along with each question. So if you're preparing for ISRO Technical Assistant or ISRO Scientist, I would recommend you to watch this video also, because as I said earlier, I have tried to include new concepts along with each questions. So I hope this video was useful for your preparation. If yes, please do give it a thumbs up and also share this video with all your friends who are preparing for AFCAT examinations. Let maximum people know that there are being classes or preparation classes being done for this specific examination. Please do share with all your friends. And if you want more videos, please do subscribe to the channel.